this lesson is the product rule, the quotient rule, trig rules. Product rule. The first times the derivative of the second plus the second times the derivative of the first. The quotient rule, the bottom times the derivative of the top, subtract the top times the derivative of the bottom, bottom squared. Let's practice. So number one, we're going to use the product rule. So the first times the derivative of the second plus the second times the derivative of the first. That's it. No more. Sure, I have room. Here, this is going to be obviously the quotient rule. What's that? The bottom times the derivative of the top, subtract the top times the derivative of the bottom, and then the bottom squared. Number three, neither one. We're just going to write this as negative 9 over 5, x to the exponent negative 2, and then we're just going to do the power rule. So that's always easiest. That's positive 18 over 5, and subtract 1 of the exponents. So if we have different rules we can use, whichever one's the easiest one. For number 4, you're given f at 2 equals 3, and the derivative at 2 is negative 4. It says find this. So the derivative of g is the product rule. That's the first times the derivative of the second plus the second times the derivative of the first. Then we're going to plug in 2 everywhere where there's an x. And then we're going to finish it. So 2 times 2 is 4. F prime at 2 is negative 4. F at 2 is 3. And 2 times 2 is 4. So this is negative 16 plus 12, so that answer is negative 4. All right. Graphs of trigonometry. Fun stuff. Graph. Sine is a wave, starts in the middle and goes up. The period is 2 pi. Has intercepts and so on. So we're going to do the derivative of sine. So plot those points and understand the derivative. So the first one, the slope here is 1. So it starts at 1. Then here has a 0 slope. So it's 0. At pi, it's negative 1 is the slope. You can see the pattern that I'm creating here. And then you think, what did I just draw? And the answer is, I just drew cosine. So the derivative of sine is cosine. Beautiful. Here's a bunch of rules. Whoa. The derivative of sine is cosine. The derivative of tangent is secant squared. Put that in. The derivative of secant is secant tangent. The derivative of cosine is negative sine. The derivative of cotangent is negative cosecant squared, and derivative of cosecant is negative cosecant cotangent. Notice derivatives with co all start with a negative. That's a pattern. The other ones don't. There are patterns here to look at, and you just simply need to know these. Differentiate each of the following. So sine over cosine is the same as tangent. And then the derivative of tangent is secant squared. 2x cosine x is the product rule. The first times the derivative of the second, that's negative sine, plus the second times the derivative of the first, and it's done. It says find an equation of a line tangent to the graph of this, sine theta over theta, when theta equals pi. So theta is like x. We still need a y value, so we're going to plug in pi. The value of sine at pi is the y value at pi, which is 0. So 0 divided by pi, that's 0. And then the slope. Well, I need to take the derivative using the quotient rule. That's the bottom times the derivative, oops, that's positive, of the top, minus the top times the derivative of the bottom. The derivative of just theta is 1, and then the bottom squared. And then I need to plug in pi to find the derivative of that. So it's pi cosine pi minus sine pi, oops, all over pi squared. That's a lot of pi's. Yummy. So cosine pi, so probably good to have a picture. This is where pi is. So cosine's the x value there, so it's negative 1. So this is negative pi. The value of sine at pi is 0. That's the y value, so I don't need to go subtract 0. And that's over pi squared. So if I put it all together and simplify it, I get negative 1 over pi. So the equation of the tangent line would be negative 1 over pi. It would be theta, not x, minus pi, and then the y value, which is 0, but I don't need it. And there's your answer. Mr. G Math over and out. I'm proud of you, and we're going to do the assignment next.